So here what we're doing is we're changing the volume that we're asking for on the keyboard input and demonstrating that it will then run for a different amount of time.
So for our code, we have the motor on pin 9, and we have variables for volume and duration, which will be used later. In the setup, we begin with a serial port, and then we ask it to display a message for the user when there is no input. And then we have the motor off initially. And then in the loop function, once input is received, the Arduino will parse the serial input into a number, which is then converted through the volt-to-time function into a duration for which it will have the motor on pumping liquid.
Okay, so this is our circuit. And what we have is a transistor right here. We have power going into the transistor. The right part of the transistor is acting as a gate, and when voltage goes through that, it's gonna then let voltage continue to go through the second and the third parts of the transistor. The second part of the transistor is connected to a diode and also to the motor, and the diode's function is to keep back voltage from the motor out of the rest of the breadboard and the rest of the circuit, and then from the third part of the transistor it goes straight to ground. We also have a multimeter here that's serving as our battery because it's a more constant and steady current than we could get from just a 9-volt battery.
Alright. For our structural device, I'm just going to put the motor in real fast. So we started out with a press-fitted box. So this top piece right here was 3D printed by Miriam. And then inside here we have some laser cut wheels, and we have this laser cut acrylic piece that's going to spin the tube. So yeah, do we want to demonstrate? So here, right now we're giving it a voltage of 9 volts using this more powerful motor. Go ahead and make it spin. Yeah.
So for an input that I said, as a user, I said I desire an input of 10 milliliters, and I type that in and I hit enter, and then this is converted to the running time for the motor.
Right. So, yeah. And yeah, that's basically it. This top piece is just kind of preventing the top from coming off. But yeah, I mean, that's basically it.
Filming.
Alright, so we're going to put some water in the tube. So our system was designed so that when this inner wheel spins, it will compress the tube enough to push the water through. Unfortunately, we couldn't really find a good balance between compression and letting the motor turn, but we're going to demonstrate what it would look like. So you want to turn it? Well, I think most of the water's out now.
Yeah, and the water all ended up in there. This was unfortunately because of gravity, but if we were able to find the proper balance in terms of the wheel size such that the force would be strong enough from the motor to turn the wheel, but also there'd be enough compression, then it should work like just how it did.
Yeah, if we increase the compression, the motor wouldn't be enough to turn it. It would cause too much friction. So we couldn't find the happy medium, but we got really close.